Hello everyone, hope you are doing well. I am Ritesh Kumar, Social Media Manager at Advantage. So, today on behalf of Advantage, I would like to welcome you all for the webinar on the topic Artificial Intelligence, its application and opportunities for oil and gas in downstream sector. I would like to introduce you with Mr. Nitin Kumar, who is General Manager at Industrial AI and Data Science at Geo. He is making a humble attempt to show how to bring AI close to industrial systems. He is armed with the latest in AI ML and data analytics. I'll request all participants to please keep yourself mute. If you have any doubts, please don't hesitate to ask Scout, or you can drop your query in the chat box. Sir, now I would like to hand the mic to you.
Hi, I guess I'm audible.
Yes, sir, you're audible.
All right, and I'll be sharing my screen. Hold on. Okay. Okay. Is the screen? Is the slide visible? Is it good?
Yes, sir, I can see your screen.
Okay. Good. All right, guys. Thank you very much for joining on this weekend evening. I believe pretty much everyone must be on the uh, high of the festivals we just finished, and good wishes to everyone for and their family. Uh, so today's session is kind of unique from what exactly uh, all over the places you must be hearing webinar about AI and pretty much application in oil and gas. Uh, the idea is that this sector is divided into three streams, which we know as upstream, midstream, and downstream. And each of them have different kind of a data structure, or at least a data fidelity, which comes to when it comes to generating data from the systems or the processes involved in the each sector. So upstream is more discrete and it's not directly connected; it is loosely connected. You can only have certain amount of accuracy. As you go midstream, it is much more of a supply chain, logistic, and distribution problems. And as you go downstream, it is more like physical and deterministic side of things, right? And there is a huge amount of control component when it comes to this. Okay. So my attempt today is to give you an idea about how to go ahead with AI, ML, and the how to look forward for an opportunity in oil and gas in downstream sectors, where exactly we start from refining of the crude to petrochemicals, and then further downstream to fibers and other specialty chemicals, right? This session is just a precursor of a very large course which we are designing, especially for oil and gas professionals, control, instrumentation, mechanical, and all the engineers who are disconnected or at least been seen disconnected from computer science and all. They are supposed to go, if they get to this particular session, they will be armed with the technology and at least the thought process to apply AI or any kind of DS downstream into much more of a how do I say application centric mindset rather than execution centric mindset. Okay, so this is what the first precursor will be. uh, my introduction is just a lazy copy of my LinkedIn profile. As you might be able to see this here, um, I'm basically a oil and gas guy for last 20 25 years, and I worked in pretty much every kind of company in oil and gas, from automation, design, process, to optimization, to simulation, and now I'm actually leading a group in Reliance, right? My experience ranges from refinery, petrochemical complex, and all kinds of automation system. And you are welcome to join, connect with me through my LinkedIn profile. Right? So today's topic is basically going to be a short one. It's going to be covered in three different sections. Okay, one is the industry overview, how the industry is organized, why exactly the industry looks like the way it looks like, why we are looking for AI prospects to apply in that industry, which is much more legacy. Okay, and what could be the expected application and what could be the outcome which we are trying to figure out. And this is how my talks are covered. And anywhere anyone has a question, please you can ask me to stop and I can explain that question. Because this is not a heavy presentation, it's not about dealing with what coding and what application algorithm models, all those things, those are later. But this is more of now how to generate a mindset or how to prepare yourself to learn this technology to apply on something you already know, right? So that's the coverage of this particular presentation, right? So we'll go through the origin of oil, what is the value chain distributed between these three sections, upstream, midstream, and downstream. How is the industry ecosystem evolved? What are the economical factors? How AI is being applied across value chain? What are the new research area which is challenging for us? If possible, we'll discuss some case in downstream, some gaps and challenges, and what are the parameters to understand the outcome in terms of efficiency, sustainability, and profitability. Correct? All right. So we kind of understand this, that basically oil has an origin in its prehistoric times, when a lot of small marine organisms started depositing in the sediments, and sediments get on permeated across the layers, and ultimately when oceans receded, or at least there is substantial amount of pressure on top of this particular sediment, this organic matter started converting into crude oil, right, and gas. This is kind of the biological understanding about how this origin of crude oil happened, and that's how we figure out, okay, this is most probably this is the theory behind crude oil. Okay, and it has been proven also, and it has now been tested also, right? So we know that the crude oil gets trapped, and we can go for excavation or exploration and production from it. Okay. How does crude oil become so valuable, and why exactly petrochemical and oil and gas is so much of a value is because of basic nature of its particular carbon. Okay, carbon has four valency, and four valency can be easily filled by single valence hydrogen. Okay, this is shareable bond. That's why it becomes it's very uniquely identified as one molecule. That is how you say that it is having a one molecule composition, and that's kind of a unique property, right? And it has a property of binding by it, sharing the bonds also. So carbon carbon can join together, and carbon carbon can share bond, and can have multiple bond also. And then also there is a possibility of unstable bonding also. Okay, so most of the nitro compounds and most of the explosives are having a bond which is very lightly connected. With the smallest amount of trigger, it gets explosive, right? That's how this carbon becomes very unique in its properties, and it becomes a problem with it becomes a kind of a building block for many types of different kinds of compound. Okay, so you can imagine this is limitless, it is still being explored. You can create new fibers, new properties of the change in the structure of the molecule, change the property of the whole system. And that's how we get so many types of plastics, so many types of filaments, so many types of fuel, and different types of properties of gases also, right? So that's a uniqueness of carbon, and that's why whole industry is now after this, or has been after this for last so many years. It's kind of what we call as the molecule which started our modern lifestyle. Okay, then there is mechanical features also, where diamond crystal can also be part of the carbon family, but this is not from a process industry, this is from a mechanical structure, but it's still worth mentioning, right? Any questions on this aspect? Right, can move on. Okay.
Yes.
Okay. So now, since we know what is carbon, what is crude oil, and also we know that they are actually very specific in their structure, and based on that structure, actually there is lot of value in it, right? So we need to understand what is a value chain for this particular crude oil to the time it's come to a product. Okay, and as you search, when you search oil and gas value chain on Google, you will get thousands of images, some similar to this. And also I did this from there, some kind of website. This is to clear the point that the reason why it is separated in multiple streams is because the skill set and the demand of that particular stream is different from are different from other streams. I have been fortunate to understand and at least see the life cycle of the crude oil from upstream to downstream to retail in my professional life. I worked in oil and gas upstream, then I also worked in midstream, and then I worked in petrochemical refinery and downstream retail, LNG. So pretty much this whole picture is very much meaningful for me because I see when you start from upstream section, say for example, we call this as ENP, that is exploration and production. You start with something to look out for oil. How to find oil is a big data science problem. You start with seismic survey, wherein you send the X-ray, the when you send the ultrasonics and other kinds of waveforms below the Earth's surface and catch the reflection. And with the reflection and refraction, you understand what is the surface phenomena and how does this surface actually can assist in holding oil. Okay, so you estimate this across wide areas of acres and acres of land, and then you pinpoint where exactly you want to drill or test the well. Okay, before this there is a lot of data analysis keep on happening back and forth, and you start drilling. While drilling also you have lot of probes which can go down, which connects to which collects more data, understand more lithography, more understand the layers and different kinds of phenomena, and then you get more data. So the data, when it comes to drilling, it gets more. Then you start with discovery, it gets more data. The more and more you get, till the time you are in development, you are very certain at which particular area of land you can get maximum amount of return from an oil reserve. Okay, and then you start developing that area. Once you develop, you move the production platform or production pipelines, and you start creating a system where it can be tapped, bring to surface. Till the time you bring to surface, it's what we call as a upstream. Okay, starting of oil distribution to oil transportation to different different users are kind of what we call as midstream, and it contains trading, transportation, storage, and refining. Okay, trading is basically, see, once you get the oil out of the surface, it's a commodity. You can say that, okay, I have a certain amount of oil in certain amount of quality, quantity, and grade. You can create a particular character sheet. You can sell it in the market saying that, okay, this is the oil I have, I can sell it in the market. And that's how most of the energy exchange in the world works. Okay, it's a commodity which is sold. So crude oil is a very highly tracked commodity based on many factors. Its prices affects, and it can be sold in the market. So this is how trading is important, and this trading is also a big data science problem. It asks for how do you connect multiple variables for crude pricing. Okay, and multiple aspects of crude to that demand and supply of it. Say, for example, you have a very low grade crude, but the demand in some kind of a refinery is very high. So you can balance it out, saying that, okay, demand is high, my quality is low, so I can sell my crude a little bit higher than the market demand because I am actually meeting some demand, right? So that is possible in doing so, and then trading is basically a big part of data science or AI ML in midstream also. And many of the hedge fund companies do this kind of analysis for crude oil, okay, or gas also in that matter. Okay, then transportation and storage. uh, Imagine you have to send a gas or container from Qatar to Japan, and then you have to understand there are quantity. I'm getting feedback. Is there somebody's on mute? Unmute. Okay. So imagine you have to send a gas of LNG gas or gas for some other purpose from Qatar to Japan, and you have storage in both the ends. You have LNG storage in the Qatar dock, and you have LNG unloading storage on the Japan side. And these are the tanks which actually helps. So the production is happening and storing in the LNG, and then there is a ship which has its own capacity, and then ship when goes from one port to another have to go through specific loading, docking, unlocking, undocking, and then coasting, and then all this time The LNG is in liquefied stage, which is 161 degrees C, and it is having constant boil off, meaning the LNG is getting evaporated, and that evaporated LNG gas or natural gas is going used in the diesel pump or diesel motor of the particular ship to run that ship. Okay, so this ship is actually using the fuel which it is transporting. So how to optimize that particular route so that when it loads from Qatar to unload to Japan, and when exactly Japan should raise the demand so that the time of the transit to the time it comes to the port of Japan has the maximum amount of delivery of the fuel, right? So this is a problem where you can create a lot of logistical solution, supply chain management solution, optimize the whole route, understand, bring in the weather component, bring in all kinds of variability, and then create a system which can optimize, saying that my ship when starts for Qatar will reach this time, this much fuel it will be used, this much of the delivery will happen. Okay, and that way they can plan their LNG demand in the whole of the country, right? So there is possibility, and that's how I feel like there is a huge use case of dynamic data science also, and dynamic AI ML kind of thing, which can do something of a it can actually work as a Google map for basically LNG transportation, right? Next is the refining part. This is another, it is mentioned as a very small aspect, but it is a very, very complex operation wherein lot of process engineering, control engineering, instrumentation, automation, and pretty much all kinds of fields come together to make the transition from crude oil to the identifiable products we use these days. Okay, so the identifiable product may be the gasoline, the petrol, the diesel, the kerosene, the naphtha, and petrochemical feedstocks like ethylene, BTX, benzene, toluene, xylene. All those things can be processed in the refining sector and then sent to downstream sector. Okay, so this is a very complex operation, but it requires a special skills in chemical engineering, process engineering, control engineering, instrumentation, mechanical, all kinds of fields are involved to run this particular operation, right? And the AI ML footprint in this sector is very, very minimal these days because this is a highly complex integrated operation which requires very close coordination of control systems. And those control systems are evolved from a mathematical and control theory background. Okay, when you align AI ML to control theory, you will see that there is a huge amount of similarity of how these two systems are evolved. Okay, uh, AI ML will be much more targeted to much more open or much more distributed, meaning it has its component which is readily build act as a building block. But control system is also having the similar mathematics, but it is targeted towards a system which is supposed to be controlled on a feedback loop. Okay, so once we go through the course, we will actually have a topic on control engineering, on control process systems, so that you understand how AI can match these highly efficient control management. Okay, when I talk about control management, you can imagine that this is the same systems which are running your trains, aeroplanes, and your nuclear power plants or anything. So there is highly credible, highly reliable systems which are capable of handling such kind of a very high demand control. Right? When I say control, you can imagine this is similar to your air conditioner working in your home which has a cutoff point of 23 24 degrees C, whichever you set, and it will maintain that temperature in the house, and it will keep on running, right? So similar thing, when you want to control operations to run at particular flow, temperature, and pressure set point, the control systems are capable of doing so with respect to all kinds of disturbance and variability happening from internal to external systems. So internal disturbance can be variability in in the process. It can, the flow can go up and down. Some kind of shutting of valve, opening of valve can create disturbance, and external disturbance can be ambient ambient temperature disturbance and ambient temperature variation up and down, atmospheric pressure up and down. There could be rain, there could be something, or vibration or wind flow. All those things are disturbance. Right? Okay, so I have discussed upstream and kind of my midstream. The refining also somehow transition to downstream also. Okay, and there is this, you can see this particular transition is happening very quickly from trading, and trading is kind of going towards refining also a little bit. So the lines are not that exactly clear, it is somehow blurry, but we know how to identify which place what goes. Okay. Similarly, petrochemicals, distribution, and retail marketing. Petrochemicals are kind of your polymer sector, your specialty chemical sector, where it actually mimics the operation of refining, but it is much more controlled towards molecule management. Okay, what I say by molecule management is crude oil is a complex mixture of molecules of carbons with multiple chains and all. That's a complex mixture. That's crude oil. Refining also is a complex mixture, but we are trying to filter it into what certain bandwidth. Okay, like your C1 to C4 will be your gas section, where you exactly you stop at butane and you say that propane, butane, ethane, methane are kind of gas, and which are like fuel gas and LNG kind of component, right? Your LPG is propane and butane, right? So then you can say that downstream of that uh, C4 to C4 to C10 is kind of your mid segment, or your liquid segment, which are actually having your fuels. So your gasoline, diesel, all those things. Diesel can go up to C12, but after the C12 it becomes very heavy, so it is not possible, right? So these are actually your category of your particular type. Still, it's not pure. Like gasoline is not pure C5 or C6, right? It is a combination of C7 to C8 or C6 to C8. Okay, that's kind of what we call as octane rating. No? C8 is the octane rating of a fuel. Higher the octane rating, better the fuel. Okay, so gasoline is there. Diesel is a little bit beyond, right? The reason why we are able to do this, because after refining and after reaching a particular group of components, we can ascertain that this component will act similar. Like C4 and C5 may act similar in properties of fuel burning or maybe lubrication or something. Or if you're saying C17 and 18 are like more like polymer, they will act little bit more like polymer. So we can say that bulk property categorization of particular groups can provide you a product kind of product. So that's why refining is much more like a category of bulk properties, and petrochemical is much more like a segregation of molecule. Okay. So when I say petrochemical, say for example your ethane, right? Ethane is the primary gas which goes to the petrochemical complex, and then ethylene goes into for ethane goes into the cracker, then it changes its molecular structure and becomes the precursor of polyethylene, the ethylene gas. Okay, that ethylene goes to the polymerizer, and then becomes a polyethylene pellets. The reason we are able to do that, because once you have bulk products, you can go for any kind of formation in multiple industry. So the polyethylene becomes the bottle or any kind of plastic thing which we see, and your butane and butadiene, toluene and xylene becomes the precursor of the rubber industry, and then similarly many other complex becomes the for the fiber and very specialty chemical industry, right? So this is a very interesting part where you can take a one particular aspect and you can become a very expert on this. Or like me, I am more of a generalist, because I find every aspect of it very fascinating. So I am very curious all the time, and I've been studying this industry for last 20 years, and still I'm not able to scratch the surface. So any questions on this? I believe I have given a good amount of orientation, but there is still a lot to talk about. Okay, I'll move on. Uh, do stop me if you see any questions coming on chat or anything. Eh? Right. Quickly on the overview, I think you already have seen this, but at least I have already spoken about it. This is upstream ecosystem. You have all kinds of companies which are operating company, service company, third party, trading contractor, and you do all these all sections actually are doing their own functions. Okay. This is our global demand and oil discoveries which are going on. It will plateau, it will go down, but at least right now we are at the top, okay, somewhere here. The oil pricing is the most critical part, which is affected by production and expansibility, currency rates, its weather condition, just few of the factors which affect oil price in the oil market. downstream processing industry actually process more than 3,000 products, and these products are already evolving. I think now recently someone from somewhere, they actually discovered a couple of more types of fibers which can be used in space or something. So that is also there. But it has been serving the lifestyle of ourselves in the modern age by giving us all this product and viable solutions for our demands, right? For our daily life. You can see crude oil going into multiple streams, providing you multiple raw material to do things which you can run your life on. And it is basically, you can say that oil serves so many aspects of your daily life. You can see it from here. Okay. This is your oil mix of every country, how much of the crude oil and gas and nuclear, and what is the, this is actually your energy mix of each country, right? Uh, we are still having on heavy on the coal, but after some time it is actually reducing. So it's kind of changing. The coal is still heavily available in Asia, so we are using it, but that also is going to change. Okay, so now that was all the industry overview. I will now transition from what are the effect of computers and hydrocarbons and all over the industry. Why exactly we are so much technologically demanding, right? So if you can imagine, primarily the idea of understanding any kind of phenomena based any kind of phenomena we observe was primarily empirical prior to like 1600. Empirical meaning you test, experiment, and you make your hypothesis, or you trust your hypothesis. Okay. Then it came with theoretical science, that the evolution of labs, the evolution of experimentation, evolution of design of experimentation created a surge in theoretical science, where exactly you can find fixed functions, you can find constants, you can find some paradigm equivalence, and you can say that one particular thing connects to through another using some kind of formula, right? Then it come to the power of computational science, where you can do large kind of permutation and a combination and find whether this theoretical science hold true or not, or is there any divergence. You can understand where exactly the boundary are, where are the constraints and the limits are, and how it is actually closing the understanding, right? That was the time till 2010, and post 2010 we are coming back to the fourth paradigm, and I think this is more like first paradigm, but powered by data science. The reason is data science gives you the power to actually test your hypothesis quite fast, rather than going through this particular cycle of finding the theoretical bias, then you testing it with computational science, then you establish your hypothesis. Data science that says if you have an observational vector, you can just create data science solution and test your hypothesis whether it is true or not. Okay. So for this example, let's just say you're walking on a park and you see particularly around one particular bush, the butterflies are actually flying in particular fashion. Okay, they are flying in particular zone, and it is actually just flickering around. The butterflies are. You take data, you take pictures, you analyze, you think that this your ground is a reference for reference axis, and you create some vertical axis of imagination, and you create this data points. Okay, now once you created those data points, you have two options: either to create a function which represents the locus of this particular observation using empirical science, or you feed into a ML algorithm and say figure out what is the function which is representing this set of data. Okay, an ML algorithm will do the job, and it will give you a function, or at least a model. When you say that, okay, if my butterfly is here, then how much is the distance where exactly it is located in the some other reference frame, right? So it will give you that. Okay. Okay, so it will give you, like, if you are saying that you're giving x-axis, then it will give you whether it is mostly likely to be found in the what kind of height, or if it is in the y, then it will give you how far it is from that particular bush. Okay, so that is the power. Okay, so that's why we are working towards this core paradigm, where it is giving me to actually bypass, or at least actually fast track my understanding of an observation to quickly go to the estimation of that particular system, right? That's where I am trying to figure out how fast we can learn a system. But today there is a problem. The problem is that AI in oil and gas is very much concentrated towards midstream and upstream because of easy applicability, availability of data, and easy connection to that data to the system. Okay, or it is loose connection to the system, so we can have a uh, very lax, or at least a little bit relatively lax accuracy towards the estimation and prediction. So the AI is right now not that prevalence in oil and gas in downstream sector, and there is a certain reason for that. Okay, see, and for any system to be understand mathematically, we need model. We call that model. Y equals to mx plus c is a model of a line. Okay, and similarly, there is parabolic and all kinds of higher non-linear models also, and polynomial models also, right? So our models, or models which are used in oil and gas downstream, are basically physical and chemical phenomena based. Okay, when I say physical and chemical, meaning these are governed by laws of nature and physics. They are they are very tightly correlated to each other. Okay, and to understand these phenomena, our modeling approach were actually very much intensive with the respect to mathematics. We are always conscious about the mathematics of a system, because based on our mathematics only we design those systems. We design a heat exchanger, pumps or valves or anything based on some formula for design, right? We started doing that. Okay, this particular parameters need to be set like this. So similarly, this much of the tolerance and this much of the design parameters will be there. So after the design, this particular system supposed to do a function based on the design which we have provided. If a temperature need to be maintained at particular temperature, it needs to maintain it because we have designed it. So the problem is reversed from all the AI case in the world. Okay, AI ML case where you have the data, you don't understand, or you have some kind of fair or not fair understanding, but some understanding that okay, this data is coming from some source which is giving some kind of a correlation, but I don't know the exact function why it is doing so. So you do start learning from an exploratory analysis. You start with supervised and unsupervised learning, and you figure out what exactly the function and the correlation between the data points. But in in a deterministic side where exactly it is governed by physics, we are much more we don't have a problem of understanding whether the data is related or not. We know that if there is a temperature change, that means there is a temperature exchange happening, or a heat exchange happening. That's why there is a temperature change, and we know the temperature change formula. We are interested in some other parameters which might be deeply affecting that data or deeply affecting that phenomena. Okay, so our modeling approaches are always constrained and based, and it is having a certain accuracy criteria. So for that, we usually depended on linear, non-linear kind of modeling, discrete and continuous systems, static versus dynamic is there, explicitly defined or implicitly defined problem statement, uh, deterministic modeling, or probabilistic or stochastic modeling. Can we do this or not? Okay, and there are two major corners of the world which are like, you can say, first principle model, and then there is empirical model, and both are used in the industry in some degree or some time together. Okay, so so far, any questions? I mean, there is. I'm rushing towards the very detailed part of it. So if there is any questions on that my explanation, please let me know. All good? Okay. So let me go on with, now. If there is data, that means it's coming from some source, or it's coming from, uh, how do I say? It's coming from some kind of a system which is generating that data. So how is this information collated, or at least categorized in the whole industry? And it's a huge amount of data. If you talk about big data, you have no idea what industrial data is. There is no term for defining industrial data. Imagine a sensor sitting on a particular system for last 50 years, and every millisecond it is generating a data point. So how much of that data will be? Is it beyond? It's not going to be beyond that what you can see in the data in financial sector. It's going to be beyond that with that much amount of data. And we are not dealing with one sensor. Thousands and thousands of sensors in a very simple refinery exist. And if you talk about Jamnagar, which is the most complex refinery in the world, with a higher Nensel rating than anything in the world, the Nensel rating defines how much of a complex system it is, and it is high complex and highly automated. So imagine the amount of data available in that, in this industry, okay, or in this particular system. Even uh, imagining that itself gives you fear of data actually. So, but there is a system to collect this information, and there is a way which has been designed by experts in the field to how to collect this information and categorize this. Okay, this is a representation of the system which is generating data and manipulating data or manipulating information in the industry. And you can say that we start from level zero. Level zero is your sensors to signal collectors or to data logger or anything which is converting a digital signal to analog and analog to a mathematical number and storing it. That's where level zero, your sensors and signals are there. Okay. Now, this is, you can imagine this is a millisecond to microsecond. My millisecond is why? Because every sensor has a sweep cycle where exactly it has having a frequency and it works on a principle of excitation. If change in process happens, where exactly the process has changed its state from 1 degree to another degree or the sensitivity level, then it will detect a change and send that signal to the central location. Okay, and that could be millisecond to microsecond. Millisecond can be a pressure sensor. Microsecond can be a vibration sensor, wherein like your aircraft rotator is moving at a very high speed, and high speed creates kind of a momentum in the shaft. And if there is shaft, there is any kind of how do I say, metallurgical crystal which is stuck to during the process of forging or manufacturing, and it can generate vibration which can damage the whole shaft itself. So there is huge concentration on high-speed machinery of turbines, gas turbines, compressors, and this kind of jet engines, which collects the data in microseconds and sends the information for the shutdown system or alarm system, so that appropriate action can be taken to avoid any kind of damage. So this is that critical. Okay, from microseconds to go to seconds, where we are talking about feedback loop of a PLC or PID controller, where exactly it is taking, say, it's like your nervous system. Okay, it's taking a feedback, meaning your sensor in your fingertip is going to sense, the skin is going to sense the change in the temperature. It sends the signal to the whole nervous system, and it says that is it warm, hot, cold enough, or too hot. If it is too hot, and it will just say that now the section goes to the manipulation layer or the actuation layer. The actuation layer is your muscle, and gives the signal to contract so that you can safeguard yourself. So that all happens in this particular layer where we call as sensing and actuation and control. Okay. Then we go much higher. You can say this is SCADA, but it is HMI, and monitoring and supervisory control. In process industry, we call APC control or RTO control. Okay, APC is advanced process control, and RTO is real-time optimization. And then ultimately it goes for manufacturing execution system and ERP. One of the thing which you are seeing is the change in the time frequency. The data is constantly changing, and the flow stops here. After this layer, it is not connected, these layers are not directly connected to the production system. It is more of like, how do we, what are we seeing, how much we are seeing, and how do we guide the below systems to make changes to the system, right? So this is what the degradation changes are. Okay. uh, One of the guideline standard which decides how do we organize this complex ecosystem is defined by IIIA standard, which is ISA 95. Okay, ISA 95 gives the how do we connect to this information system, how do we address this thing. Is there any problem with my display? Shall I reshare? Okay, I'm resharing just in case. Okay, just let me know if I can see the screen again. Is it good?
Okay.
Okay, yeah, that's what I'm trying to project now. Industry overview, information flow. That's what it is. Okay. All right. So now you are able to see this is how the whole information flow happens from top down to more bottom up. There is different ways to connect to the system, and every layer is having a potential of AI and ML use case. Okay. Is it not yet seen? Um, I changed to state of present model. Okay, what's happening? Yeah, I guess it takes a little bit time to come on computer. Okay, okay. Let me know if it is connected again. If it is good, I will start continue. Okay, good, good. So, okay, I guess it's believed to be with bandwidth also. All right, people are able to see now. Uh, so in industrial AI application basics, we can say that it is driven by kinetics or driven by some kind of a formulation where you can say that product A goes through a cycle of making product B and C, and that converges mixed to become a D. That could be one. And you have multiple ways, mathematical representative of this particular kinetics. It could be a power law approach or other kind of approach, which is designed by multiple chemists in their labs. But this is still explicit way of defining things. So you can see that this is not only easy, not only difficult, but is highly complex because it is just an estimate. People say that this particular entity behaves certain way because we have observed it saying behavior. We have not experimented or at least defined why it does so. It just does so, right? So what could we do best? We cannot throw the knowledge which we have gained for last 100 years, and we cannot stop. We cannot just sit while we wait for our knowledge to evolve to AI. Okay, what can we do now? So I will suggest we do take advantage of hybrid models, where even we know that something we understand from previous work history and the way we have developed in the industrial sector using the process principles and combine that using artificial intelligence and create a hybrid modeling. Okay, it's basically under still development, but there is good amount of traction. Okay, any questions on these? I believe I can rush. There's huge amount. There's quite amount of time have been taken this, but this is the start of things. Okay, so as I said, AI models are kind of gray and black in nature, meaning it doesn't really tell you what exactly is the function in. It just gives you what exactly the phenomena you are reading, and once they read that, once it learns that phenomena, it gives you a out in respect to input gives you output. Okay, but it doesn't tell you what exactly is the phenomena. Okay, it's the function. Okay, so if a model is developed by using AI, it requires a deterministic model because we are dealing with industrial systems. If industrial systems by which I can say that any kind of decision needs to be taken, pressure needs to be changed, temperature needs to be changed, flow needs to be changed. It needs to be properly validated. Okay, because it can be catastrophic to do some kind of action which is not properly understood. As you can imagine, industrial systems are large volume, large containment of chemical entities. If a gas gets released and if it is a toxic in nature, it can wipe out a population in the area, or it can have a very bad effect on the environment. Similarly, if you are saying that your model is so good, it should be that critical that you are able to think that this model is able to run a nuclear plant. Okay, that much criticality should be there. So it needs to be properly validated, okay, and properly based on the principles of engineering. Okay. You need to understand how mass balance works, okay, how cause and effect relationship in the chemical processes works, and how are they correctly captured or not. So you need to have a proper boundary on the model. So hybrid model set to achieve larger role in continuous plant operation. You can imagine that there is a time which is going to be a time when models will be self-improving. Okay, meaning, say for example, you have a car and it is running from when you start the car, you own the car the first time to the time it has run for some 4 5 years. You see things are not exactly smooth. The drivability is not that smooth or something. The AI model in this case is you as a driver who's driving that car from the start. You need to update your driving style, or you need to double your force you require for taking change in the force or something else. uh, what you're doing is you're evolving, you're improving your understanding of that system which you are running. Similarly, if you put a model on a machine, the time it is very new to the time it has degraded, the model which is running that machine should also improve its understanding. So that's where I want to tell you that this is self improving model, which is almost close like human operator. Okay, there could be good amount of predictive simulation and analysis use case. What are the frequent and recommended action? How to use, easy to use and maintain. How can we do sensor upkeep and maintenance, and maximizing to constraint. Okay, so maximizing is constraint is kind of a very new concept. The idea is, again, I'll go back to the car example. Your car is supposed to run in a very high efficient manner with very very safe parameters of all the equipments on machinery and the part. Okay, but the certain constraints are there. Constraints are like seal temperature, which is coded at 200 degrees C, and some RPMs or some kind of gear ratio or something. These are the constraints which are there. Okay, or load capacity. What if a smart F1 driver does is actually he maximizes to constraint, meaning a F1 driver pushes the car to the limit so that he can do best lap. Okay, that's where I'm talking. Right now, we are driving our industry like a truck driver or a lorry driver. We are not maximizing to constraint. We are maximizing to most optimal safe places. Okay, we need to be very much aware of maximizing the constraint to our industry, so we can get highest throughput and highest efficiency, right? So that's what I am. The application of artificial neural net and deep neural net is going to be provide that capability, and that's where we are going. Okay. Now, why we are so much happy is basically we are saying that the tools are free, so we can do a lot of experimentation. We can go ahead and create a lot of chemical process and deterministic model. Okay, so this is just few of the points which needs to be considered. Okay, and this is use case like column fouling, performance degradation, liquid to compressor, and all are in development, which you can say that this is secondary phenomena which you can not see directly by a sensor, but it affects your performance and efficiency. Right? Then you can optimize your complex reactors, okay, and you can understand the internal kinetics and better control those reactors, and find what are the hidden opportunities. Right? So now this is the last slide, and I want you guys to understand that okay, this is our next proposal of this series of lectures or course is going to be. We are proposing a structured course with assignment and vetting process, so that we can specially prepare people from the for process and chemical industry or industrial applications. Uh, I want you to guys to understand that industry is basically not only just oil and gas, but you can see alumina industry, process, fuel, pharma industry, paper pulp, and fertilizer, and all those industries are basically running on the same principles of control and optimization and process. Okay, so this is where we are planning to do those. So we are also saying that we will introduce chemical engineering, chemical process, how ML is used in these processes. What are going to be the process control and optimization using AI? So that will be part one and two. There will be plant and plant engineer, how to prepare for AI. So this covers not only chemical and process and controls, but also instrumentation engineer, mechanical engineer, civil engineers, and architects to understand how AI is coming to their industry and bring change for their career. Right. So this is going to use end to end of many use cases from inception to orchestration, right? Starting from how to figure out to do modeling to how to put that model in production. Okay. Then how enabling tech for AI like cloud architecture and infrastructures or IT are actually giving you control over AI ML. Okay, and how to pivot your career to a new age technology fueled career rather than struggling to find why exactly these new words are coming in my field. Will be more prepared to take on to the next career. Okay, and not only AI, we are looking beyond AI where it is going to be autonomous, intelligent, and interactable. Okay, we are talking about next level Siri in the industrial section, or next level Google, which is going to change the whole industry. Right. So this is where we are looking ahead, and I thank you all for attending this call. Hope I made good discussion, good points to expose the potential of AI in the industrial sector. Any questions? I'm open for that.
Hello, sir. Yeah, generally, which are the platforms suitable for combining with AI and ML? If there is a model, we know the modeling tools like Aspen, IFIS, or uh, Aspen Plus. So, which are the suitable platforms, maybe supporting this Aspen, IFIS, or
Yeah,
Aspen Tech
there are two
platform?
thoughts or two schools of thought. That is, first is property-based applications. There's are like Aspen, Unison, HiSys, and all those. These are property-based civil applications where exactly you have a database where you understand the binary and tertiary interaction of molecules and estimate the effect of those changes in the physical aspect of those molecules and predict the outcome. That's one. Uh, these are limited to the database because what is happening is Aspen Plus is not completely having the whole polymer structure or polymer molecules. So it might be having some molecules of methane, ethane, propane, which are good to simulate in a lab, and based on that, they have generated a data bank. Okay. So they are still limited in understanding everything about that about a physical phenomenon. Okay, still there is a lot of assumption and presumption in the simulation world. These platforms are coming from a deterministic side of things, meaning they they know the mathematics or they have some idea of mathematics inside, and every kind of formula is figured inside them. Okay, so they work on a degree of freedom principle. So if you have two information, third will be able to predict. Okay, or such is the setup of the whole Aspen or any kind of simulation world. Okay, they are now able to attach a data model to them to uh, help them better understand what is physical. It's possible. Okay, every company is offering one platform to work in the industry. Aspen is offering, Honeywell is offering, every company is offering one platform. And then there are initiatives like where we are also able to develop using AWS, Azure, anything, and we can do our own platform. It doesn't restrict us to do anything from non-Aspen world. You don't have to restrict. You can understand the phenomena better, or you can create a validation pipeline, and you can say that okay, if my data model is doing something like this, it is validated by the simulation, and it is doing good. So they both worlds are available. Aspen world is available, and non-Aspen world like Azure and data science is available. Only thing is you need to understand the mathematics and functionality of that system.
Yeah, because why I asked this question, because you mentioned about the hybrid models, right? So Aspen is coming up with hybrid models for reactors. So is
It's
it the
been long
same
before.
kind of models? Same kind of
Uh,
models what you are referring?
yeah, yeah, similar kind of model. But when I say first principle is just a coded equation. If you know the equation and a power law equation, that's a first principle model,
Correct.
and you can attach a data model to that.
Yeah,
Okay, and that can be done without Aspen also, because
correct,
what we
correct.
see in the reactor model in the deterministic software, The reactor model most of the time starts its journey from a deterministic equation, but it creates a envelope of operation from minimum, maximum, normal to turn down and all. And it says that every point is maybe here, here, it's all non-linear, but it is connected with a linear regression in between.
Okay. Thank you.
Okay, and uh, may I know the name who was asking me question?
Yeah, my name is Sumit, sir. Sumit.
Okay, Sumit, you can connect with me on LinkedIn. We can have a good conversation
Sure,
on this.
sure, sure. Yeah.
Okay. Anything else? Okay, we can close the call if not, if it's all good.
Okay. Thank you very much, sir. Thank you, participants.